Thank you. Hello. Can you hear me? Okay. Hi. So first I need to do a disclosure. I have no PhD, and I'm also not Roger, the CEO. I'm the sales guy. My name is Volker. So I'm going to talk about how we intend to revolutionize AI compute with an NPU based on RISC-V, if I can make this work. Okay. So we call this thing Cervell. And the question is, what the heck is that anyway, right? So Cervell is a neural processing unit IP. And it can, in a standard setup, it can offer up to 256 TOPS in int4 at 2 gigahertz. The key point is that we use our IP blocks to customize or configure it to people's needs. As I said, we have standard offerings, which I will share, but there is also customized configurations available on request. So why does anybody need this? The target applications are classical convolutional AI networks, processing end-to-end. That's very important, okay? Because everybody talks about the so-called NPU TOPS and forgets the configuration and the after processing. And, you know, when you add all this up, you get a third of the frame per second. So, of course, transformers is a big theme. Large language models is very sort of modern these days, and generative AI. The whole point is that this thing is entirely based on enabled by the RISC-V ISA, and I'm explaining you why. Why an NPU based on RISC-V ISA? Now, I'm not sure who of you has been in the NPU market, but I want to dare to say that 99% of the NPUs out there are based on proprietary and secret instruction sets. And the AI models which have to run on those are changing and evolving very fast. Typically too fast for these IPs or for these chips which are in the field, especially if you're in a high-performance, high-end market where it takes you already 3 years to bring the chip to the market. By the time it's out there, it's obsolete. Okay, so it's very difficult to ensure that the hardware is actually executing the stuff which is coming in 3 years down the road. Now, RISC-V ISA is suitable for modern, and in this case modern means parallel, workloads. It has vector instructions, which in this case serve as what people otherwise know as GPU, under the same ISA. That's very important. And of course, the vector instructions enable very efficient and effective handling of big amount of data. One instruction gives me a lot of data, okay? So, and the software support can be based on a very generic RISC-V toolchain coupled with open source schemes such as ONNX, which we have chosen. That enables the users to have a very high, previously unseen degree of freedom to deal with model changes and deployments of innovative AI compute workloads. That's why we do this. So just to give you a little bit of an idea, you may have heard earlier about what we call the all-in-one RISC-V compute element, which we've put together by our IP. There is a little picture there. The key point is that is having, of course, the CPU, vector, tensor, but it's not separate units. The unit here is to illustrate the thinking of the people they have, but it's not units. It's instructions. It's one IP. Instruction by instruction, you can decide whether you do scalar, GPU, respectively vector, or tensor. So here are a few examples of configurations. The idea of this is two things. Number one, we'll configure this thing as the NPU from 8 to 64 TOPS at 1 gigahertz in int 8. And there are some degrees of freedoms, and I'm not sure to what extent you're familiar, but, you know, again, I'm coming back to this NPU parts and the TOPS, and well, you need more TOPS. Guess what? If you have a large language model, it may make no difference whether you have 4 or 8 TOPS. Why? Because all the other calculations are on the GPU. Okay? So the point I'm making is with people who know what workload they have, we can optimize this thing in PPA and performance to their specific needs. So that's going to be all sort of internally hidden. As you can see, activations can run up to FP64 in the data center, but I think in a mobile handset, nobody needs FP64. So that's kind of stuff we will deal with to optimize this thing for the people who need what they need it. So software support, very important. Key point here is that we've done a whole SDK we call Aliado with the very standard RISC-V stuff such as the IDEs or the QEMU, compilers with and without auto-vectorization. And we've also added what we call AKL, mathematics library, which can do transformations and, of course, also support neural networks. The key point here is that whilst we talk about NPU and in the past, when you have any of those, you're totally dependent on some sort of proprietary machine learning compiler hoping it does what you want. In this case, it's all transparent and you can see it and it's stuff you know. And if you want to scale this, that's what we also do when we put it together. It's like a multi-core. So it's a very familiar way of doing things. We're just trying to make it very easy for people to use. Talking about AI, we've decided to focus on the support using ONNX, i.e., very clearly, we don't have a machine learning compiler. Right? The key point here is that ONNX is open source. We'll provide the runtime. We provide all the operators you ever need. And we have some extra tools, for instance, like a quantization recommender. If you have a bandwidth limitation, how can you go about it to optimize your software or your weights to manage the bandwidth, right? We also have a model zoo of models which we've already ported, and we can also demonstrate. DeepSeek, yeah, that was, as you may have seen. Yes, sir. I'm okay. So DeepSeek, right? Early this year, suddenly there was DeepSeek, and it was like, can you run this thing, right? This is some of the details of these models, and in PyTorch it looks like this. So can we support this? Of course we can. We take the model to Onyx, we create the runner, and we run it on this IP. And here is a screenshot and what it means. Yes, we can run it, and we did this in less than 3 days. Okay. So whoever has ever had an NPU, tell me whether you can do this. Less than 3 days. Here is an idea of the model zoo of stuff which we've already done. As you can see, there is no detailed benchmark. That's the part which we disclose under NDA. But you can see we've already tested these things under this and run this. And that's it. I gave you back 1 minute, right? Thank you. Thank you.